Okay, so today we're going to talk about the chain rule. So what does the chain rule actually do and allow us to do? And so if you notice, I have two columns there. The first is without the chain rule. The second is with the chain rule. So the ones on the left are problems you could actually do now. Then what ends up happening is if you look on the right, you're going to notice there are some distinct differences. Okay, and the first distinct difference is you're going to notice that it's got a quantity. Okay, you've got a square root of a quantity. Okay, you've got the sign of a quantity. You've got a quantity to a power. And this tangent x squared, once again, it's tangent of a quantity. And so that's what we're going to do. We're going to look at how can you find the derivative of those individual terms. Okay, and so what we're going to do is we're going to learn something known as U substitution. Now this is something that will follow us through to integration as well, so it's important you get it down. Okay. So what I want you to get down here, this is the chain rule right here. Okay, what I want you to get down here, you can actually, if you wanted to, write down this right here. Okay, and another thing that would probably be good to be written down would be this right here. Okay, no jokes about the FU. Okay? So anyway, if you notice the chain rule, we have the derivative of f of g of x. So basically, this is like a composition of functions. These are two functions in one. And how you find that is you find the derivative of the outer function and you take that times the derivative of the inner function. The easy way to remember that is the derivative of y, or dy, equals f prime of u times du. Okay, f prime of u times du. And that's kind of important to remember. All right, so we're going to go ahead and look at a chart here. And we're going to fill the chart in. Now what this chart is doing is it's kind of preparing us to find the derivative. There's kind of some background knowledge that you need to have before we go much further. Now if you look at this very first thing right here, this is my function. I've actually got two functions in one. Okay. What would be the quantity in this problem? I'm just going to ask this and see if you can come up with it without me telling you. X plus 1, nice job. So that's what u is. In this case, u is going to be x plus 1. So now I'm going to rewrite the original function y using nothing more than u, or numbers. So if I use nothing more than u, this is 1 over u. Okay? What would be another way you could write that? U to what power? Negative 1, good. Now like I said, this is going to look a little foreign until we actually find the derivatives. Right now we're just kind of doing the preview to the derivatives. So what would be the inner function in the next one? What would be 2 what? 2x, very good. So if I rewrite this using nothing more than u, what do I get? Sine of u. Okay. What is u going to equal here? Okay, good job. What does y equal? Square root of u. What would be another way that would be derivative friendly? U to the 1/2. Good. Now it's important you understand when I said derivative friendly. The square root of u, it's going to be hard for us to find the derivative that way, but u to the 1/2 we can. Okay. Now this one, you got to be careful on this one. Tangent of x. Now if you remember, whenever we see that squared up there, that essentially means whatever that function is, quantity squared. Okay, so that's what tangent squared x means. And so in this case, it's tangent x. And then what does y equal? U squared. Good. Now, the first few problems on your homework, that's all you're going to be doing. You're going to be finding u, and you're going to be writing it as your function with respect to u. And so on these first few problems, that's what we're going to start with. We're going to find u, and then we're going to find du. Did you have sheets today?
Yeah.
Okay.
415, got it. I already had it.
Okay, so if you remember, the very first steps are to identify u and du. Okay, so I'm going to start with u here. What is u in this problem? X squared plus 1. Now we're going to do something a little different that we didn't do in the other page. We're going to find what the derivative of that u is. And what's the derivative of that u?
2x.
2x, very good. Okay, so we've kind of done the preview work, almost. The last thing I need to do is write this in terms of u. And what is it in terms of u? U cubed. Okay. So, before we go on, are we okay? All right. So now what I want you to do is I want you to find the derivative of u cubed. So what would the derivative of u cubed be? Good. 3u squared. Now we're going to have to do something a little different. We're going to take it times du. The reason we add the du is because we're actually finding the derivative of x. Okay, and so since now we've got du in there, the variables don't match. And I'll explain that more when we get to section 2.5. But you always need to add that du on. Okay, so our final step is going to be to plug in u and du. And that's it. Okay, so I've got 3. It says u squared. So x squared plus 1, quantity squared, and then times du, which is 2x. Very good. Final step will be to simplify those. So what do you get here? Close. Simplify. Notice what I've underlined. Six x times
Squared plus 1 squared.
Oh, that's all.
that's all you can do. Okay, now on that one, I mean, you could FOIL out the x squared plus 1, but you don't need to. Okay, leave that factor. Okay, so let's go ahead and look at the next one. All right, it says find the derivative of f of x equals 3x minus 2x squared. So let's go through the steps.
X minus 2x squared.
There you go. 3x minus 2x squared. That's your first step. What's the next step? du.
Minus 4x.
Okay. What do I do now? U cubed. What do I do now? Close. There we go. 3u squared times du. Remember, we always got to add that du on regardless of the problem. Okay? So what do I do next? Yep. Okay. Quantity, oh, oops, just a second. Forgot the squared, sorry. Squared, and then times 3 minus 4x. So now obviously you can't combine what's inside with the square. So I know that one term has got to be this. But you can combine these two. Okay, So what is 3 times 3 minus 4x? 9 minus 12x. And then I'm going to take that times 3x minus 2x squared, quantity squared. You could. Okay. Now, just a little tidbit. Come test time, if you forget the chain rule, there is another way to do this. And that is to multiply this out 3 times. And then just find the individual derivatives. Okay, so you would FOIL out 2 of them and then multiply by a third one. So that is an option. Let's go ahead and look at this one. Okay.
X squared minus y squared.
What do they have this period?
But they're just making
Wait a minute.
Okay, what I'm going to do before I continue is I'm going to go ahead and rewrite it. So what will it be? Close.
1/3 of 2
Oh, 3 halves.
Close.
2/3.
2/3.
2/3.
Okay, so remember the power always goes in the numerator, and then if the cube root or the fourth root or whatever root you're dealing with goes in the denominator. So now in this case, what is u?
X squared minus y.
X squared minus 1. What's du?
2x.
2x. Okay,
Wait. How'd you do it?
that's the derivative of x squared minus 1. So let's rewrite it. What do we get? U to the 2/3. Good. Okay. What's the derivative of u to the 2/3?
2x.
2/3 u negative 1/3 times du. Now what I'm going to do is I'm going to simplify, obviously. I don't know why I put parentheses around the u. Okay, but I'm not going to erase them, so anyway. If you're wondering, was there a reason why she put the parentheses around the u, the answer is no. So, I'm just going to warn you. So now let's go ahead and plug in what we know. We know we've got the 2. We know we got the 3. I've got x squared minus 1 to the 1/3. And then I've got to take that times du. So du is 2x. So your final answer will be, yep, over 3 times x squared minus 1 to the 1/3. And there you go. So that's the chain rule in a nutshell. Now the chain rule doesn't just apply to algebraic problems, it also applies to some trig problems, and I'm hoping that I have a trig one next. If not, we might skip it. Yeah, we're going to go ahead. Real quick, how would I rewrite this one just for kicks?
Negative 2.
-2. So it'd be 2t minus 3 to the negative 2 power. Okay. All right, here we go. We go to some trig functions. Now I'm going to be honest with you. Okay, these first few are actually really easy. Okay. What does u equal? First one.
X minus
X minus 1. What does du equal? 1. So really, y equals cosine of u. What's the derivative of cosine? So I end up having negative sine u times du. So I end up having, what is my final answer? Of parentheses, x minus 1. Yes, I boxed it. All right. What's the next one going to be? What's u going to equal? 3x. Good. What's du going to equal? Okay. So really, y equals what? Tan of u. So now we need to think back to our derivative rules. And like I said, I'm going to end up having a reference sheet for you that will have all these on there. What's so secant squared u du. Okay, so really my answer will be 3 times the secant squared of 3x. Now, you're probably wondering, you know what, I'm going to draw that box again. I know, I ran out of, there we go. You're probably wondering, where did the 3 come from? That's the du. I just moved it in front at the start. And so, yeah, you need to have the constant out in front. Okay. And if you don't, because some people would assume that that's 3x times 3, and it's really not. The 3 is actually one that goes in the front. Okay. Real quick, what we're going to do here is we're not actually going to solve these problems. We're just going to identify u and du. What is u in the first one? 3x squared. So du would be 6x. Okay? What's u here? What's u here? Okay, you need to understand what powers and their locations mean. This means that the 3x is squared. So essentially, the problem is the cosine of 9x squared. So in that case, by simplifying now, we can identify u as 9x squared and du as 18x. Okay. There's a big difference in where the power is located. Look at the power here. The power here means the x is squared. The power here means the 3x is squared. Okay? Big difference. And last but not least, what does that power there mean? That means the cosine is what is squared. Okay, so it's one of those you kind of got to learn what all of the powers mean. And so what is u in this problem? Cosine x, yep. What is du? Negative sine x. And we're actually going to solve this one because this one gets kind of an interesting answer. So y equals u squared. Okay. So y prime is 2u times du. So now I get 2 times cosine times sine okay. By putting the negative in front, you usually don't put it, because if you put it after, or if you put it between the cosine and the sine, it's going to be cosine minus sine. That's how some people would view that. So make sure you put the negative. Yeah, but you still need to put the negative around front, okay? Because anything like that belongs in the front. All right, here you go. 1 through 27, the odds, 41 through 46, and 49 through 52. Now we're going to continue with this section on Monday. Okay, so you're probably going to have a short quiz again on Monday, and we'll continue with this section and finish it up Monday.